Alright, so today we're going to be building a water heater for my 18-person hot tub.
Donkey's breath.
This so far is the rough idea. Using one of these. It's going to hold 6 of these guys. About 9 kilowatts at 240 volts. Let's do it. Alright, so if you have no reference point, I'd recommend picking out the earlier videos, but you don't need to. We're just building a heater. I built like a 5,000 liter hot tub out of basically a concrete form that I built from scratch. But we're going to implement a 9 kilowatt electric heater. So the idea is I have 6 of these guys. These are 1,500 watts each at 240 volts. So then I need to build a core. This here is old hardened steel. It's bandsaw. It's plasma cut. I drew all the sides up in CAD. Plasma cut, so that's why all these holes aren't very perfect. And then I just welded it all together. I'm hoping it doesn't leak too bad. This end we're rocking a flange right here. So we're gonna be welding a fitting on there. That's inlet or outlet. The other side is an inlet outlet. Basically what we gotta do is we have to embiggen these holes along the top here so we can actually fit these in and then fasten them in. And because it's hardened steel, all I'm gonna do that with this die grinder and we're gonna get on with things. All right, we're good. We got all the 6 holes embiggened so they fit. So these all just come out like this. So I put a lock ring in on the back one. I'm hoping we can see in here a bit. There's just a 1-inch lock ring, stainless steel, holding that in there. But on a funny side note, the threads that these come on are not National Pipe threads, so they're different from all this other shit. But these lock rings are so thin that the threads don't fight each other enough so you can actually thread it on, even though they're actually the wrong thread to my knowledge. But anyways, it's pretty much perfect, and that folds up and seals. It's a little bit narrower for the seal there, and this should work out pretty beautifully. I guess this next thing is to get this flange to fit on, because not all of the holes got plasma cut just right, so I had to embiggen some of them pretty much from nothing with a torch, where I put this all together. By the way, I'm sorry there's no footage for that, but I think I did it well enough here. And this one here just is like misaligned as crap. So we just need to do a little bit of work on that one right quick here. All right, so we got it fitted on there nice now. It's playing nice up top. So I'm just gonna take this back off and we're gonna get these holes in the end embiggened and we're gonna weld fittings in right about now. All right, so I've got both of them welded in. Don't worry, that reducing nipple is just there to cover up the nice threads we're gonna use later, as well as this cap is just there to cover up the threads. But definitely not my best work, but she'll do with maybe a little touch-up work. We're gonna assemble this here. Alright, so here's the setup. Put a little bit of air in it. This is kind of dangerous. It's only meant to be used for fluids, and it's going to be pumping at a maximum of like 60 psi if someone blocked off. But operating pressure is probably like 20 or just flow, something minimal. So right now we're just trying to look for leaks. This is not meant to be a pressure vessel by any means, but we're just putting a little air in it, using a little bit of Windex, can find some leaks here. There's one. That's actually a pretty good edge. Only one little leak in this corner. All right, so I tacked up all of my little leaks that I had marked up. I still don't believe it's perfect. If I were to do this again, I probably wouldn't grind all my welds because I think that actually exposed a lot of areas that weren't sealed up that would have been left that was fine. But it looked like shit before, so it kind of looks like shit now. But it's kind of like a prototype, but we're definitely gonna try and use it here and finish it to make sure like this whole thing is feasible. But yeah, I'm gonna throw some paint on this, on the inside, on the outside, and the inside to try and fight back a little bit of the corrosion that's gonna happen once we introduce water and heat into this. And of course, air bubbles, rust, it's gonna happen, but gonna give this a paint up and then we're gonna start looking at the housing and the electrical. All right, so this is all kind of like looking like a mess. We got 6 of these, and basically to control those, we have a 40 amp solid state relay right off of Amazon that came with this temperature control and thermocouple. So math works out, these together, 9 kilowatts at 240 volts, should pull approximately 40 amps. All right, where were we? We got so really interrupted. All right, yeah. 40 amp solid state relay, temperature control, thermocouple. This is gonna be a power meter just to see how much this actually uses. And we got the little CT core that comes with. Along with, we're gonna have 4 indicator lights. One's an alarm light, and the others are just going to either come off some of the contacts on this guy because it has multiple set points, I do believe. And we also have some dryer switches, which there's 90 degrees Celsius normally open and 60 degrees Celsius normally open for indicator lights and a safety shut off so the unit never gets to boiling is one of the goals. But anyways, it's kind of like a fuck full of shit right now, but I'm gonna draw up a proper control scheme after it's done, once I figure out what I wanna do, and we'll run through that on paper and hopefully things will make a little bit more sense. So I'm gonna get these in here. All right, so we're moving along here. Instead of using this heat sink guy here, we're just gonna use that as a heat sink. So I'm just gonna kind of plop that guy right about there. And this is a good time to bring up, since there's only one relay and 240 volts and a neutral involved. So it's, you know how it is. It's actually not a very safe setup at all because it means one side of these heater cores are always going to be energized unless you throw the GFCI breaker. So like that's just one point to like how this is not actually that safe of a setup. So don't try this at home, kids. Shifting focus back over to my Majestic heater core here. We're gonna put these in for the last time and rebutton this flange up and start letting that RVT, I think it is, chooch. One last look at what we're doing here. Got them all sealed up in there nice. Got a little bit on them, but shouldn't matter too much. Just final look inside before we seal this puppy up for good again. Hopefully for good. Never to be opened again, but I doubt it. All right, so as this goes on more and more, it becomes a little bit more of a prototype as we go on. Because frankly, I wasn't that prepared for what I wanted to do here, but we're doing it anyways. It's gonna be like single use, but anyways, we're building a little bit of a tray to hold the heater and the control box. And it's just gonna be real bloody simple. It's gonna be like, just like that. Straight down here. All right, so that's what she looks like in the stand so far. We're gonna spray foam her in just a wee bit, a little bit of insulation. Good way to hold it in there. Be able to cut it out or rip it out if you ever needed to. But we're just kind of going for it here. All right, she's all shaken up. All right, and today is tomorrow, and everything's like, this is all firmed up in here. And we're basically gonna start with the power wiring on this thing and go forth with that. Speaking of the power wiring, each one of these pulls 6.25 amps on when you do the math. So I'm gonna use this 18 gauge TWE, 105 degree rated. It's, looked up this actual wire's spec, and it's 6 amps at 30 degrees ambient. So this is gonna be more than 30 degrees ambient, but I'm gonna push it. I'm gonna call it close enough because it's just jumping from here to here. And once again, this is just a test. So yeah, I'm just gonna go ahead and wire this all up. All right, so I kind of jumped way ahead and did pretty much all the wiring, but start with what we got here. Everything in blue is neutral. So we got the 3 indicator lights we're using, all of a neutral going to them. Temp control has a neutral. This guy doesn't because it's on 240, so it's line to line. Red here is just the L1 power for temp unit. We have an indicator power on light, and then we have one that goes up to a normally open, normally closed relay within the temperature controller, which then is on the 2, then off here and here goes to each indicator light, different colors. That's self-explanatory. We have the CT for the power monitor, just around L2. And then we have the thermocouple coming in here on those pins for the temp control unit. And the last thing we have is the solid state stuff on the 2 pins that's designed for on the temp control unit. The negative goes right to the SSR, I'm sorry if you can't see it here. And then the other one comes out of the control chassis here. I don't know what to call this little box, control unit. Just gonna close her up right quick here. Oh, something's crunching. Breaking stuff. Sorry, to continue off where we were, coming out of the enclosure, we got off the positive of the solid state relay pin off the temperature controller. We go through a normally open 75 degree dryer switch, and another one over here kind of hiding under this insulation here, and then coming back and hitting the relay, which then would turn the relay off if either point on this enclosure reached 75 degrees C, and that's the safety. But this is a good time to bring up that this unit is by no means safe. There's no fusing for any of these smaller conductors. It's controlled by a solid state device, which when they fail almost all the time. They fail closed, which means if that fails, the only way, it's either going to trip the breaker, you're going to trip the breaker, or this thing's going to melt into it. I can't open that with that. But cool. Everything looks good. Just double check that these were not energized with my meter. But one line up there is energized, so there's 100 volts, 120 volts across these guys here as we speak. So if you're building something similar for yourself, aka take my advice, don't unless you really know what you're doing and you're doing what I'm doing. Other than that, you should not be doing this. Alright, I got it kind of configured now. I can't exactly remember where we left off in talking about this, but I think I explained pretty much everything. But finally got this controller to work, got her energized, she's running in PID mode. But we're going to hook some water up to this and give her a chooch. Alright, so bad news. We sprung, other than the leaks on the loose fittings, which I expected, it worked pretty good except for this one heater core sprung a leak. A pretty hefty leak, if you don't mind me saying. Alright, once again, not sure exactly where we left off, but we got her back in. She dried up, a little heat on her for about 6 hours. So now it's full of water. The loop is running. We got a little test setup going here. So we got this whole loop has 20 gallons of water in it. Little giant pump pumps out through this. Both hoses are in this insulation here. You can see where it got melted from the wood-fired version previously we've used. Input here, all this water here is just from this being a little bit seepage, and hopefully not the actual tank there. Yeah, we're good.
And this guy I've messed around a little bit with. I think I'm not done with this yet, but well, that's interesting. These are just solid right now. I'm not sure if you can see this on video, but with the camcorder on its display, they're like going across in lines. It's an interesting effect. But yeah, we're gonna let this heat up until this gets stupid hot as a little test. I want to see some really hot water in there, but this is looking really, really great. All right, so you know earlier when I said these SSRs fail closed? Well, I'm not sure if it's that the duty cycle on these things truly aren't 100%, or if it's because my heat sinking to this enclosure wasn't good enough. But let me tell you this, I can't physically touch this plate right here for longer than that because I'm gonna burn myself here. It is stinking hot. None of these conductors are melted, but it appears this has failed either to bad heat sinking or I'm just screwed up and they're really not meant to be 100% duty cycle. But it was pulling 37 amps, it's a 40 amp solid state relay. I was rated for the voltage and current. I don't know what the fuck went wrong, but we're gonna have to go for a, other than that, everything worked perfectly. This guy went into alarm because it just kept heating up and heating up. And minimal leakage, totally acceptable. So we're gonna do something about that. I'll have to pick something up local tomorrow. It's probably gonna cost me a bit of money, but it's not gonna be cheap Chinesium shit. So yeah, there we go. All right guys, ready to see some dirty moves here? So I took apart this relay that blew up on us. So this is the sticker, SSR 40DA, right? Look on the board, this is actually the Turtle SSR-10DA. This is a 10 amps, so the actual switching transistor, or whatever have you be in here, is actually just, it's the 10 amp board rebranded by these motherfuckers as the 40 amp and expecting people to oversize and not and have it like fail. But of course mine failed right away because I was pushing pretty much 40 amps through it for a solid 20 minutes and she went pop. But those dirty buggers, you can't even blame me on this one. Alright, so this time we got some real hardware here. Things are gonna get safer. We're gonna do things a lot more proper. We're gonna have more indicating lights. Lots of good stuff happening now. So I went out, spent a little bit more than $100 Canadian and got a 40 amp rated resistive contactor and because this has a 120 volt coil, so this is a 12 volt coil, 120 volt ice cube relay 8 pin, and things are looking up. And I had to add this second closure because there's not enough room in this one. They're just together, so they're just gonna both sit just like that, and it's gonna be beautiful. So I'm gonna continue wiring this up here and we'll get back to you in a minute.
There's nothing left for me to do than run and act myself a fool. No point in trusting anyone. Your eyes of diamonds keep me up.
Look at this beautifulness. First test run before I tied up all the electrical inside, and everything's looking pretty beautiful. So set point is 28 degrees centigrade. We're at 28.9 right here. That's what this here is at. Output temp, about the same, of course, because it's not actually on. So now I'm going to manually override this to get this to go into alarm mode and check that that works. All right, so we open up this one. We find ourselves control relay. We manually engage it. These two come on, indicating that both sides of our contactor have emptied. You can hear this gurgle a little bit. And this guy should alarm, I think it's around 32 or 34 degrees is the set point. I left this thing alone for too long. And high temp alarm is going crazy. Exactly what I wanted. Alright, so now I've set everything up to it happens to be 79.1 degrees Celsius is what we're set to. I raised the high temp alarm to 80 degrees or ish, 80, I think it was 85 degrees. And basically what I'm doing now is, I may have mentioned before, there's two 75 degree normally open dryer switches here and here, just right up against the chassis, pushed in on the foam. Sorry, you can't see that there. I'll zoom in for you. Hiding like right under there. There's a switch. And when it opens, when this chassis gets to 75 degrees centigrade, and at this flow rate, I want to discover what temp of water, input temp of water, has to be reached to set those puppies off. That's the idea. Progress update here. So we're at 52.4 degrees Celsius on the input water temp. Output water temp I can only guesstimate, but it has to be lower than 75 degrees C. But you know what I just realized? It's pretty much going to be a fight between which one thermals first. Whether it's going to be these guys here, thermal first at 75 degrees C, or the thermal overload on this Blue Giant pump in here, because of course it's submerged in the water that is 50-ish degrees centigrade. When it goes, because it'll go eventually, it'll thermal out, or this will thermal out first. And it's kind of a race, so I'm just waiting here to see which one goes first. Just kind of see the limitations of this setup. I'm sure we could get this to boiling if we didn't have those two limitations, but there's no point with dealing with that much hot fucking water. Anyways, we'll see you when she thermals out. Alright, there it is. They just thermaled out at like just under 60 degrees C. And this is probably still going up, possibly just due to a little bit of convection currents in the bath. Going around, it kind of floats a little bit. But yeah, we're just gonna wait here until they come, until which one of these that tripped out comes back. And I'm hoping it's this one, because that would make the most logical sense. Which one tripped out?
Night is cold, but your heart's colder. I will wait for you. The glitch in your eyes pull me under, but I will wait for you. There's nothing left for me to do but run and act myself.
So as you probably just saw there, I just foamed up everything, insulated the whole thing. We got pretty much all the way around. You can see the top of each still, so if you ever need to troubleshoot for whatever reason, you can still get your leads on there. Other than that, everything's perfectly encased. There are a couple you can still remove and put somewhere else, but I did decide, slightly out of laziness and the fact this is a prototype, that I'm not going to tie up my stuff here until it's proven. So that's basically all we have here, except I'm going to draw up the control scheme for this, and we're going to go through it. Other than that, we're basically done here. And so let's get to that. Alright, so I'm hoping following this isn't too hard, but basically we have a little bit of a control drawing here. We have L1, L2 on the far right, neutral here. So first off, the green light is just from line 1 to neutral. It's on all the time when the unit has power. The next line goes through an on-off switch, which isn't labeled yet. I'll put some labels on that later. And then that powers on our PID temp controller, which also has a neutral out so it can get power. We go down, ties onto this relay that's built into the controller, which is the normal state versus the alarm state. So it's normally closed to an orange light, and then normally open to the alarm light slash buzzer. So when this goes into alarm because of over temp or under temp, if you have it set, this will switch, that alarm will go, this will go off. We have a thermocouple output, which I haven't drawn in here, positive, negative, goes to your thermocouple wherever you want to go. Then we have the SSR out, which is a 12 volt out, rated for 3 amps. It's going down to control coil 1, which is that relay, and then back up. So whenever that gets energized, the control coil is on. Also, after this on switch, we have our other switch, which is our on off for the heater switch, which isn't like a manual override, it's a turn off, so you can still program this without it turning on in case you're in a dry scenario where you don't want it on. So that switch, when closed, then it goes through C1, normally open contacts, which is from here,
So when this closes, these will close. Then it goes through the 275-degree safety switches are normally closed, and then to the power coil of the contactor, and then back to neutral. And below all that, we have from line 1 to line 2, we have our power meter, because it's all in 240 volts power meter, and then out to our CT for the power meter. Second drawing here, this is more of the power side of things. We have L1 and L2. L2 goes through the CT, back to the power meter as I just said, then through the power contacts of the contactor, and then down here, these are our 6 resistive heating loads, 9 kilowatts total, 9 kW heating loads, all paralleled up like that. Off of each one, we have a red indicator light after each contact going back to neutral to show that they engaged. However, in this circuit, if say you had an open right here, like for whatever reason you had an open right here, or this didn't close even though they would totally close together, you had an open here, these would also, this light, this here light, the second red, will also illuminate, because it's like a couple milliamps or whatever, 20 milliamps draw, but it would be at 240 volts, and then these here would total like 3 ohms or something, minimal resistance, so it would act like a 240 volt circuit, which wouldn't be 240 volt because it's back to the neutral. These both would still come on. Hypothetically, one might be dimmer than the other, but anyways, you really only need one. I have 2, but that's the way she goes, and that's the total drawing. If you guys have any questions on any of it, just please ask, and I will try and answer your questions the best I can. Alright, there she is. I hope you guys get a little bit better understanding what's going on here now with that drawing explained. But yeah, just a piece of tech. And here's the GFCI. You can catch that before. Plugs into any range, but right now that's how she's set up. So I mean, thanks for watching. If you have any questions, just give me a shout in the comments.